Integration by parts. So we've got two differentiable functions, u of x and v of x. And first of all, we're going to recap what the product rule is. So the product rule is the derivative with respect to x of the two functions multiplied together, uv, and that is equal to u dv by dx plus v du by dx. Based on this, what we can do is rearrange it to create a rule for use when integrating. So the first we're going to do is integrate both sides. So we will have the integral of the derivative uv with respect to x, and that will be equal to the integral of u multiplied by dv by dx plus the integral of v du by dx with respect to x. The integral of a derivative is itself, so we'll just have uv on the left, and then on the right hand side stays the same. Oops. And the right hand side stays the same. So the right will be the integral of u dv by dx plus the integral of v du by dx. What we can then do is rearrange this, so we will have the integral of u dv by dx with respect to x is equal to uv minus the integral of v du by dx. And this is our equation for integration by parts. Just before we go on to an example, we just have a small matter of which values do we pick for u and which one for dv by dx. So to pick which component will be u, we use the mnemonic latte. So L stands for logarithmic, so any component involving logs will be our u. The next would be inverse trig. After that will be algebraic functions, then it will be trig, trigonometry, and finally exponentials. Whoops. So if there's a logarithm in it, pick that first. If there's not, then we'll look for an inverse trig. If there's neither of them two, we'll go algebraic, then trigonometry, and finally exponentials. Now on to a question. Okay, so using integration by parts, find the solution of the integral of x e to the negative x with respect to x. So looking at this, the first we got is an algebraic function, which will be our x. So we're going to set u equals x, and dv by dx is going to be e to the negative x. We want to differentiate u, so we'll have u dash is equal to 1, and v therefore is going to be negative e to the negative x. Okay, so now we need our equation, which we've got there, and we can sub the values in. So we want to find the integral of x e to the negative x dx. That's going to be equal to uv, so x, minus x e to the negative x minus the integral of minus e to the negative x times by 1 with respect to x. So that's negative x e to the negative x. We'll take this minus outside to make that plus the integral e to the negative x dx. Now we just got to integrate that. So minus x to the negative e to the negative x plus the integral of e to the negative x is minus e to the negative x plus c. If we then group together like terms, make it a bit nicer, negative e to the negative x, lots of 1 plus x plus c. And that is the integral of x e to the negative x.